As tempted as I am to simply weld this tripod head onto this stepper motor, I don't think I'd be too happy with myself. I wouldn't get the weld straight, it wouldn't be adjustable, and I think it'd be just a pretty janky job. So today's project is to come up with a better solution for building the rotation head for my camera system. As you can see here, I've got another stepper motor. This time I have a 15:1 planetary gearbox reduction on it. I've tested it out, the vibrations are bearable and the motion is smooth, which is good. And I have the head for my tripod. I think what I'm going to do is, give me a sec. Here's the linear rail. I've been debating about mounting it this way versus this way. I'm going to go this laying down way for a variety of reasons. It just gives me some more optionality for how I want to use the system. And I think what I'm going to do is build out of steel some box section that comes up here that allows me to mount the motor on here. Then I've got a shaft coupler, I've got some bearings, and I'm going to sort of design as I go to make a system to attach this together. I think it's probably worth my while to spend some time in Fusion 360 to just mock this up to get a sense of what I'm doing and have a plan to follow along. But I feel like kind of winging it. It's sometimes fun to just wing it. And if I screw up, I screw up, but it'll be fun. So hopefully by the end of this video, we'll have a nice, smooth, rotating head for the camera on this linear rail. Let's get to it. I think I have a plan. No, I'm going to be confident. I have a plan. I was originally thinking of making it out of steel that I'd weld together. But I think I'm going to make it out of, and machine it out of this aluminium block. Basically, I'm going to make one block that rides here, another block that rides here. They're riding both connected on the same shuttle, so they should be relatively rigidly mounted. I'll have a little bit of wiggle room side to side. But for this block down here, I will bore out to put the motor, set the motor in here a little bit, then drill some holes so I can attach the motor from this face here. On this top piece, if we're looking now upside down, I'll mount the head there. I will bore out here for this shaft or this threaded section to run through, and have a recess counter bore for this bearing. Then what we have to deal with is mating these two shafts in the center. I think I can probably turn this threaded section down to fit into one end of this shaft coupler, then make a keyed sleeve or just a set screw sleeve that runs in the keyway here. That goes to this end of the shaft coupler, and I think we're good. I decided to go with machining rather than welding because I think it'll come out nicer, it'll be prettier, it'll match the colors better, and I think it'll actually probably be more rigid than welding and having to sort of strap things together. So let's get machining. have ourselves a rotary axis. This was a lot of fun to build. There were only two areas where I deviated from the original plans that I had in my head when I was designing this. And they both had to do with the weight of the camera on here. I was sort of building this with just the tripod head on here, but the moment of inertia with a long lens changed some things. And the two things that it changed was firstly, how I coupled the tripod head to the threaded shaft that I'm using here. The plan was just simply to screw it on and have a lock nut holding it in place. That worked okay, but once the camera was on here and if you put a lot of acceleration in, whoop, you could untwist the tripod head off, and that could have been pretty expensive if I wasn't watching it closely and losing a camera. The other thing was how I was coupling these two shafts. The plan was to use one of these flexible shaft couplers. These work pretty well. This is a really cheap one and it's pretty springy. And again, with the torque of that sort of camera with a long lens, you get a lot of bounce when you have rapid changes in direction or acceleration. And you could adjust for that in software. That would be easier if I had a rotary encoder. I did sort of closed loop, but I thought it was even easier just to replace this flexible coupler with a solid shaft coupler. I was able to do that because where I wasn't able to make things precise, I was able to make them adjustable. So these blocks here are mounted to the carriage using slots where the M5 bolts come in, so I can align them in this direction. And then with some precise milling of the heights here and locating the center holes, they can be aligned in this direction. So now I have a solid shaft coupler here, and the only wiggling and bouncing comes from this motor planetary gear backlash, which is pretty small, and it's totally acceptable for what I'm trying to do. I said, on the topic of software that I was going to use this video to build this rotary head and also write the software and show how I'd build like a control system for this. But I've kind of caught the bug of building new axes for this system, and I think it would be really cool to have a tilt axis. So the plan for tilt was to sort of copy how this tripod arm sort of moved the head back and forth like this by making some sort of linear actuator that lifted the arm up and down. And one of my sort of goals, unstated goals for this project has been to just use stuff I have around the shop, not buy anything new. I buy a lot of junk thinking I'm going to use it sometime in the future. I want now to be the future. So I was really excited to crack open a silicon wafer handling robot that I also won in the same auction that I got these linear rails, and see if I could scrounge some parts for a linear actuator in there. There's a lot of really cool stuff in there. There's a really nice long precision ball screw and a bunch of 5-phase stepper motors, which I hadn't heard of before, but they do the most accurate one does 0.0144 degrees per step. That's really cool, but not useful for this. So what I plan to do, originally I mocked up a system with another just stepper motor and using just some all thread here and a nut that would sort of push this back and forth. That didn't work out so great. I realized that it was overly complicated. I was taking rotary motion, converting it into linear motion of this nut, which then goes into rotary motion of the head. A little overly complicated, but then I remembered I have my mini CNC lathe, or my mini Harbor Freight lathe that I've converted to CNC, so I don't need the change gears from anymore. So I'm going to mount a gear here, a little bit more precisely than that, and another gear here that I'll put on that same stepper motor, or maybe if I can find a geared stepper motor, that would be good, and drive the head like this. So I'm going to work on that instead of working on the software in this video. This is much more fun. Hopefully we'll get this done, and then in the next video we'll have a 3-axis system all set up. Then we can start working on the electronics, so I'm not driving it all from my test gear. All right, let's get back to building some more parts. Alright, I'm pretty happy with how this turned out. I made a few prototypes. I first started off with the motor mounted on this side with a smaller gear, but it felt sort of ungainly having all this weight dangling off here. So I went to a larger gear for a variety of reasons, and I depthed it against this aluminium block and then just, whoops, bored it out so the teeth would be depthed appropriately and doesn't bind, and it runs pretty true, which is good. I now need to bore out this hole here for a bearing. I made a test shaft for a different idea, which had the gear here and then a bearing in there. But I need to make a longer one because this one, because I wasn't thinking and I was just designing as I go, this one had interfered with hitting there, which limited my travel. So I'm going to move the motor back a bit, which means a slightly longer shaft. But boring out this block for a bearing will be fun. That's going to be a fun 4-jaw setup, and then making the shaft should be pretty straightforward. All right, let's get to it. I've been putting off some pretty necessary repairs and maintenance on this lathe. I've basically been using it straight out of the box since I got it a couple of years ago. It's developed an oil leak, or I think it's had one pretty much from day one. I've put sort of a half-hearted attempt into fixing that, but never got it completely right. It needs to be leveled. It needs to be basically torn down completely and put back together. Because right now, the power feed isn't working, and that's getting in my way. So I think my next sort of machining video or shop video is going to be a full repair of this lathe. But for now, I need to fix this power feed because it ain't working. Welcome to the belly of the beast. Got the carriage off, and I can see the problem. Through down here is where the hex shaft runs that drives the power feed. You saw that there was this bushing that fell off while I was trying to work out why this guy was loose. The reason why it's loose is there's supposed to be a bushing back here and a snap ring in a groove there. In a great bit of good fortune, while I was working on a prototype shaft for the rotation head thing, I realized I didn't have any snap rings, so I just bought a bunch of snap rings. They arrived late last night. So I think all I need to do is put a new snap ring on here, clean this guy up, and we'll be back in action. It's nice when things work out like that. With the lathe up and running again, I made a new shaft for this tilt head, welded on a little mount, and here it is on the Rotary Axis. It operates really beautifully. I also welded up a nice heavy base for this. You can get pretty top heavy with a lens on there, and this is pretty sturdy, so that'll hold it nicely. It also has a space on the back where I've attached the stepper motor drivers. Still have to attach the power supply. Started wiring everything up, and I thought that I'd give you a quick demo driving all 3 axes from an Arduino. But the moment I opened a laptop, I had sort of this loathing feeling of writing software. I need a break from writing software from now, so I think I'm going to go back to some old habits of mine. Building weird analog-ish sort of discrete electronic components. Controllers, these are video and audio, but I think I could make a nice analog-driven discrete driver for this that sort of does weird stuff. Not exactly sure what right now, but it's going to be a fun project, so that's going to be the next part. Let me know what you think in the comments. Should I just make an Arduino controller for this, or should I go weird and wacky and have knobs? I'm leaning towards knobs. Anyway, let me know down below. Thanks a lot for watching. If you like, subscribe. I appreciate it. See you next time.